Hi everyone. This is an example of a mole to mass style of stoichiometry problem. Here we go. What mass of potassium chloride is produced by reacting 0.500 moles of aluminum chloride with solid potassium? When we have a stoichiometry problem, we're going to follow the same 4 steps every time, and that starts with balance the equation and interpret the question. When we need to interpret the question, we're always on the lookout for some key words. Produces, reacts with, mixed with, something like that. Okay? And then we can reread the question focusing on those key words. This says potassium chloride is produced. That lets us know that after the arrow, we're going to have potassium chloride. And it was produced by reacting aluminum chloride with solid potassium. As we move forward, an increasingly useful strategy is to read the question and skip the numbers. Here in the beginning, there's only one number, so that doesn't really help us out too much. But it would say what mass of potassium chloride is produced by reacting aluminum chloride with solid potassium. We need to do what we need to do to wrap our heads around what the chemical reaction is going to be. Here we have aluminum chloride reacting with potassium. Aluminum is a 3+, and chlorine is a 1-, so we have AlCl3 reacting with potassium. Potassium is not a diatomic element. Metals never get a subscript. We have a single replacement reaction where the potassium is a metal, so it's switching places with the aluminum. Potassium is a 1+, chlorine is a 1-, and aluminum alone. Metals never get a subscript. We need to balance this reaction. We have 1 aluminum on either side, 3 chlorines on either side, and 3 potassiums on either side. We've balanced the reaction. We don't need states. We need to be on the lookout for questions about precipitates in particular. Occasionally something about a gas, a state might matter. Overall, though, the huge majority of the time, we don't care about the states. They're only going to slow us down. We have 0.500 moles of aluminum chloride. We have the moles of aluminum chloride. I'm going to put right underneath the aluminum chloride N equals 0.500 moles. It's the moles, so I put in N. I put it underneath the aluminum chloride, AlCl3, because it goes with that chemical from the question. Now, what else do we have? What mass? We're looking for the mass of potassium chloride. This is the potassium chloride, and we're looking for the mass. So I'm putting M and a question mark. That's why this question is called mole to mass. We started with moles of one chemical. We're solving for the mass, mole to mass, of a different chemical. Wherever the question mark is, that's what we call R. The required chemical here is KCl, and the G, what was given to me by the question, this one over here. Okay. That's interpreting the question. That's a long time. You're going to be able to go faster than I did just now, but that's step 1. Balance the equation and interpret the question. Step 2, find moles. We could find moles by reading or by doing mass over molar mass. Here, it's right in the question. By reading carefully, we could find the moles. I found it 0.500 moles. Found it. Next, we're going to multiply by the R over G. Multiply by R over G. R, the balancing number of the chemical you're searching for. When we have these labels in here, it makes it very easy. Wherever the question mark is R. It's balanced with a 3 times 3 over what was given. This was the given, and it's balanced with a 1. 3 over 1. Now, what we would have right here is the moles. If we were asked for the moles, we would stop. But we're not asked for the moles, we're asked for the mass. And the mass is the moles times the molar mass. All of this here on the board right now, it represents this red N. So what we're going to do in our final step is multiply by the molar mass. But because we have the moles, this all represents the moles of the KCl. If we're looking for the mass of the KCl, we better multiply by the molar mass of KCl, which means we need to take our time, use the data booklet if we need to come up with that molar mass. Big reminder, balancing numbers, those coefficients, have nothing to do with molar mass. We're using the balancing numbers for our mole ratio, R over G. This has 1 K and 1 Cl. Finding the molar mass, potassium, the data booklet tells me, is 39.10, and chlorine is 35.45. The molar mass of KCl is 74.55. Let's say all of this again. We found the moles by reading. We multiplied by R over G. That takes the black N and turns it into a red one. So all of this right here, all of that right there represents what I'm going to call red N. And red N multiplied by the molar mass is going to give me the mass. Because we're looking for the mass of the KCl, we had to use that same molar mass. Any values that show up at the front before the R over G have to do with the given. After the R over G, everything about it is the required. So I have my calculation set up now. Lots of things going on, lots of buttons to push. 0.5 times 3 over 1 times 74.55. 111.825 is the raw answer that comes out on my calculator screen. I need to think about the significant digits. The number in the question has 3 sig digs. My answer needs to be the same. This rounds up to 112, and we found the mass. Grams. When we're working through a stoichiometry problem, there's lots of different variations. However, we're always going to follow these 4 steps. Maybe the most time-consuming is the first step, find moles, times by R over G, and then solve appropriately. Having some labels underneath your reaction is something that's going to be very helpful to you. And overall, don't forget about those significant digits and units. I hope that helps.